we're going to start with b, and we'll do a second, and then I'll add a part c. So, in b, we have 3 equals log 2x plus 2 plus log 2x. So first of all, this is a logarithmic equation because what we're solving for is inside a logarithm. So what you need to know is to be able to understand, if I have that, my main goal is to get things to a single log so that I can, number 2, change it to exponential form, and then after that it's going to be easy to solve. Is it a single logarithm right now? No, I have 2 logarithms. And so I can combine those 2 because the bases are the same, and I have a log law that says if you're adding 2, that's the same as multiplying. And now I have a single logarithm. Once you have that single logarithm, this is the hard step to remember. This will be the step that you forget. What do I do from here? I use the definition. My base is 2, my exponent is 3. It's equal to this, which if I multiply that out, is x squared plus 2x. That's my definition of a logarithm. And the reason that's such a hard step to remember is because you're not doing something algebraic from one step to the next. You're using a definition to change this form to this form. And that's something new, and that's why you forget that step. It's now a quadratic equation. How do we solve quadratic equations? We make one side equal to 0. Factor x plus 4, x minus 2. So x is equal to 2, and x is equal to negative 4. You now have to check. If I plug in minus 4 into my original equation, will I take a log of a negative number? Anywhere. What's negative 4 plus 2? Negative 2. That would be bad. You can't take a log of a negative number, so this one will be an extraneous root. What about the second one? 2 plus 2, that's 4. Positive number. Perfect. 2 is 2. Both of those ones are okay, so x equals 2 is fine. Next, we will do part A. Whoa. Crazy. Okay. I wanted to use a button and it disappeared. Anybody see the camera button anywhere? Okay. So, main goal, combine as a single logarithm. Do we have a single logarithm here? No. I could combine these two. They have the same base, a log plus a log. That means we could multiply. But I still don't have a single logarithm. So in my next step, how do I combine logs? They'd have to be on the same side of the equation. I'm going to move this log 6x over to the other side, and then say a log minus a log, that's the same as dividing. So I do get a single logarithm. It's got x plus 6 and x minus 1 on top, and 6x on the bottom. And it's equal to 0. So now that we've got a single logarithm, now we have to use our definition. Our definition says change to exponential form. What's the base? 10. What's the exponent? 0. Equals. I'm going to multiply this out, so it's x squared plus 5x minus 6 over 6x. Now 10 to the 0 is equal to 1. If you're solving a rational equation like this, the first thing you would probably do is get rid of the rational equation by multiplying both sides by 6x. That will simplify on this side, and on this side 6x times 1 would just be 6x. And then you end up with a quadratic equation. So here, how do I solve a quadratic equation? I make one side equal to 0. Factor. And solve. So really, after this step here, it's all review. This is all stuff you've done before, and if you're not experts in it yet, you're close to being experts in that. And that's why we practice these questions, to realize, oh, that quadratic stuff and those rational equation stuff, it comes back over and over again. Now, we've solved our equation. The last thing we have to do for every logarithm equation is check in our original equation. If I plug in 3, do I ever take the log of a negative number? 18, 9, 2. It's always a positive number inside your log, so that one's fine. If I plug in negative 2, I get a negative number right away, so I can put an x through that one. Can you still see it if I make it a little smaller like that? I'll make it just a little bit. Okay. I'm now going to show you a shortcut in this equation that you could use. And this shortcut is related to something we did when we solved exponential equations. When you solved exponential equations, what was the very first thing that you did? You took the log of both sides, right? If you had something like 3 to the x equals 8, you took the log of both sides. And the reason that worked is because a logarithm is a function. So that means if 3 to the x equals 8, it must be true that you put those things into the log, it would still be equal. That's the idea. Can you see how you could use that shortcut after step 1 and right away say, oh, so that means that 6x equals x plus 1 times x minus 1. What am I doing? I'm saying if I have a log equals a log, by logic, the insides have to be the same. That would only work if I have a log equals a log. Any other numbers on there, that wouldn't work. But do you see how many steps that would save? You move right to there. Okay? But that only works if you have a log equal to a log.
So for B it won't work.
For B it wouldn't work because you don't have a log equal to a log. For C, it won't work either. Well, I'm going to make up C. Okay, log 3, 1 minus x equals to 3 minus log 3, whoops, x plus 11. So I'm making up a part C. Now, I chose this part C because I felt like the first two examples were missing a few things. In this example, you have two logs, so we need to combine it as a single log, but they're on opposite sides of the equation. So if I want to solve this one and combine it as a single log, the first thing I'm going to need to do is make sure that those logs are on the same side of my equation to see if I can combine them. Is there a log law that lets you combine them? The bases are the same. We can multiply, right? Because we're adding. So I can combine these two. I can then use my definition. right? This is the hard step that you forget. The base is 3. The exponent is 3. It's equal to 1 minus x times x plus 11. So if I expand this, I'd have x plus 11 minus x squared minus 11x. What kind of equation is this? It's quadratic. So I'm going to make one side equal to 0. I actually prefer to make this side equal to 0 because I don't like factoring when my x squareds are negative. So if I move everything over, I have a minus 10x. It'll be plus 10x. 27 minus 11 plus 16. This factors nicely. X plus 8, x plus 2. X equals negative 8 and x equals negative 2. Yes? Well, when I move this 11 over to this side to combine those like terms, I'd subtract 11 from 27. And that would give me 16. Well, I'm going to want to make one side equal to 0. So I moved everything over to the left-hand side. So what's your gut reaction to these? Will these be extraneous? Okay, and that's another reason I chose this question. Just because your answers are negative does not mean your answers will be extraneous. Negative answers could be fine. In fact, in this case, if I look back to my original equation, what happens when I plug in negative 8? Here I get positive 9. That's okay. Negative 8 plus 11 is positive 3. That's okay. Negative 8 is fine. I don't want to use red. Green. Yes. What about negative 2? Negative 2, 1 minus negative 2 is 3. That's okay. Negative 2 plus 11, 9. That's okay. Despite those answers both being negative, they both are fine. So just because your answers are negative, that doesn't mean they're extraneous. You have to plug them back into your original equation and check if they work or not. So I can make a question just like I made this one. 2 negative answers that they both work. I can make a question that has 2 positive answers that both the positive answers don't work. In fact, about 5 years ago, the final exam, the very first exam question was solving a log equation. You came up with one answer and it didn't work. So the answer to the first question on the final exam was no solution. And your confidence felt like, I just screwed up on the first question. I've got 2.5 hours to go and it's not looking good. It was a very mean first question on that final exam, but it had no solution. Because sometimes you'll get 2 answers, they both don't work. You have to put an X through both of them and just say there's no solution to this question. Okay, questions you can do for practice after this one are 11 and 13.